One thing that you may want to consider is the use of an abstract class to provide the foundation for your polymorphic types. Remember that an abstract class is basically defined as a class that contains one or more abstract methods. Abstract classes cannot be directly instantiated. Rather, abstract classes provide the foundation for subclasses, and those subclasses will provide the implementation of the abstract methods. However, you can still use the abstract class type as the data type for example, the array, and then load individual subclasses into the elements of the array. It's a great way of providing some basic structure for all of the elements that you're going to be accessing or grouping together within the nature of the polymorphic array. One thing to consider when taking this approach, however, is that any reference variable that you define will only have access to the members that are specifically defined within that particular type or above in the inheritance chain. For example, if I have a type, basically typed as dog, I would not be able to access any of the members that are specifically defined in bulldog. I could only access the members that are defined in dog. For example, let's say that we have a shed method that has been assigned or created in the bulldog class. The dog does not create or contain a shed method. Only the bulldog class has a shed method. Therefore, if we have a type that's typed specifically as bulldog, then that variable could call that shed method. However, if you have a type dog, even though it may be storing a bulldog, it would not be allowed to access the shed method because the shed method is not one of the members of the dog class. You could, however, downcast that dog to a bulldog and then call the shed method of the downcast element. Now here I'm using the same basic dog class to provide the base class structure with one little change. You'll notice that I'm using this basically as an abstract class. So I've decided just for illustration purposes to make this an abstract class. That means there must be one or more abstract methods. In my case, the abstract method is the method speak. Now remember, every abstract method is automatically virtual. That makes sense because the only way to really use this abstract method is to overwrite it within a derived class. If we go to the bulldog class, which derives from the base class dog, what we're going to see is that I not only provide an overriding implementation of the speak method here, but I'm also providing another method specifically within the bulldog class. In my case, a Boolean method called willAttack, and bulldogs return true. Now please note that the willAttack method is defined only within bulldog. It is not defined within the base class dog. Let's see what kind of impact this has on our array. What I'm going to do here is just create a simple instance of a bulldog class, but you'll notice that I've typed that as type dog. Dog D equals new bulldog. So I'm creating an element of type dog and storing a bulldog into that element. Then I'm going to call the willAttack method of that dog. What's going to be the result? Let's execute this and find out. Well, upon executing this, I'm getting some errors. Let's see if we can track down what those problems are. If we come down here into our error list, it tells us that the dog class does not contain a definition for the willAttack method. Well, that stands to reason. Even though I've technically stored a bulldog into this instance of the dog class, because I'm using a type dog for my reference variable, only those members that are defined at type dog or higher in the inheritance chain are accessible through this instance. So this is an invalid statement. Let's comment this out and take a look at a different approach. What if I were to define that as a bulldog specifically? Bulldog B equals new bulldog, and then call the willAttack method of B. That's another option. Let's go ahead and execute that and see if the results are any different. This time things work out just fine. It returns a value of true because that is the value for the willAttack method of the bulldog class. So at this point, it looks like it's worked out appropriately. Is there anything that I could have done to this initial code that would have enabled me to call the will attack method of this dog? Well, in fact, there is. If I had taken this variable d here and downcast that to a bulldog, I would be able to call the will attack method of the downcast value. However, I can't call the will attack method of dog because it's not defined at that level.